In this section, we will begin modeling mechanical items. To do this, I will open the software and select the appropriate template from those provided. So I'm working with version 2026, and we'll open this template. The second step involves linking the structural and architectural files from the Insert tab. I will choose the Link Revit option. I will navigate to the folder containing the structural and architectural files, select them, click Open. So I will wait for the files to link successfully. After linking the files, I will go to one of the elevations. In the project browser window, I will find the elevation branch under the view section. For example, I will double click on the east elevation to open it. In the template, several levels have been defined that we need to align with the levels in our architectural files. So to facilitate this process, I will click on one of the levels and use the empty circle next to it to drag it slightly to the right for better visibility. So I also have a level for the ground floor, and that I will drag it here. Now I need to align the levels from my architectural files as a reference and match them with those in the template. So from the Modify tab, I will use the Align command or its shortcut, which is AL. Here my reference is the FFL basement from the architectural file. So I will click on this FFL basement level, which is also present in the template, to align them the ground floor level. In my architectural file matches the ground floor level in the template, so I will continue this process for each level. Level 1 from architectural align with align 1 template, level 2 with align 2, I'm sorry, and so on. So for the 4 architectural in template, 5 architectural in template, 6 architectural in template, 7 architectural in template, 8 architectural in template. So some levels in my template exceed those in my architectural file, so I can select and delete them. For instance, I will hold down Control and drag to select the 2 levels at the top and press delete on my keyboard. So a warning will appear stating that 54 views have been created based on these levels, so including various floor plans and ceiling plans. So if these are deleted, those views will also be removed, so which is acceptable. Now that I have aligned the levels that were also present in the template with the finished floor levels FFL for my architectural and structural files, I will return to one of the plan, especially the one that was open earlier. So at this stage, I need to create the grids present in my architectural files within this MEP files as well. So to do this efficiency, it's best to use the Copy Monitor tool. Copy Monitor will copy items from the architectural file into my MEP file and monitor them as well. So monitoring means that if there are any changes made to these grids in your architectural file, such as their spacing or names, the file will provide a warning, including the changes have occurred, and ask if you want to apply those changes to your MEP file. So this is not just a regular copy. Copy Monitor keeps track on these elements. To do this, I will open the Copy Monitor command from the Collaborate tab. There is an option called Select Link, which allows me to choose the link from which I want to copy items. I will click on this link, which creates a new tab for Copy Monitor, and I will then start clicking on each grid that I want to copy. So the first one may take some time. A warning appears here, indicating that there was already a grade in my file with that name. So to differentiate between these two files, I've named the incoming grade by adding 1 at the end of this, its name actually. So I click OK and proceed to the next grid. Each grid I click on will create a copy in my MEP file. So okay, once completed, you can check off in a ribbon to finalize this action by dragging both grids and selecting them in the same time from the architectural file. I can ensure that I know exactly which items are selected. So to verify my selection, I can use the filter icon that at the bottom. Both sections are part of common. If you look closely, you can see that grids from the linked file are also selected. One view has been selected as well. However, I do not need this section view, so I will uncheck it. So finally, I will pin the selected files using an option from the ribbon. Pin them cannot be deleted or moved. So this ensures that if I accidentally try to select them and drag them elsewhere, they remain fixed in place. So let me demonstrate. For example, if I drag without paying attention, they won't move. By pressing Ctrl and selecting Pin again, I can ensure there's safety, so this can no longer be moved. Now that the settings have been configured, I need to modeling. I will start modeling the plumbing items from the wastewater system. Let's take a look at the plans. Please open the mechanical plane in your drawings. In the measurements section, so you have a floor plan that is of the typical type, which I can select based on my understanding. I will use Ctrl+C to copy it. Then open a new sheet with Ctrl+V and click in an empty space. So I will place the plan in the section where I save the floor plans, naming it Detail DWG, and save it as sanitary floor plan for the wastewater system. To determine which unit to link this plan with, I will take a measurement. For example, I will measure the width of this wall using the linear dimensions tool. It gives me a measurement of 0.1, which corresponds to 1/10 of a meter or 10 centimeters. I need to ensure that in this dimension style, I modify it so that there are no primary scales. This confirms that the units in my plan are in meters. So next in Revit, I will go to the project browser window, open the view branch, and then the sanitary branch to look at the highest floor plan. Let's take a look at the elevation as well. In the elevation view, we have one floor with an attic, and level 7 is the roof. For now, I want to start modeling the wastewater for level 6. And these two floors, we will model the rainwater drawings as well. So I will go to this level 6 by double clicking in it. I will open the plan where I need to link this drawing from this insert tab. I will select the link add option and choose the floor plan I saved earlier. I will check the current view only box so that this plan is displayed only in this level 6 plan. For example, I don't need to see the wastewater plane in the fire protection or heating and cooling pipe planes. The unit I measured is in meters, and I will set the positioning to center to center. Now let's see if the plane aligns correctly with the architectural file. You can align it by dragging it slightly away from the architectural space for easier marking. Select the plan and modify its alignment with architectural axis. One from this side and here as well. So keep selecting and pinning the plane to ensure it doesn't move anymore. So you can also click on select pin element and select link at the bottom so that the red cross appears, ensuring that the plan cannot be selected again to avoid any disturbance during modeling. So we will begin modeling from the restroom area where we have placed sanitary fixture in our architectural model. We will extend the pipe up to their limits. We could have placed these fixtures in our mechanical file, just like they were positioned in the architectural file, meaning there would be no fixture in the architectural file, and all fixtures would be placed in our mechanical file. Both methods are valid, and I will explain both. So in this restroom, which also includes shower area, we initially considered the shower base but removed it from our model. Instead of shower base, we have decided to use a linear floor drain here. If a shower could be were to be included, we would need both these pipes and another one based on decisions and designs we have had. I assume that I have this linear floor drain for this restroom, and I will proceed according to the plans while modeling both scenarios together. So I will use the pipe command from the system tab. The piping panel may be located elsewhere in your setup. These panels can be moved by dragging them around in the ribbon to different positions according to your version. So select the items according to where your panels are located in your version. You can choose. So, and the shortcut for the pipe command is PI. In the properties window, I need to select the material and type of connections for the wastewater pipes. Drawings should specify what material the pipes are made of. We want to use polypropylene. The valve mentioned in the beginning is an Italian brand that provides us with families of pipes and fittings. I will use those families. So the next thing I need to select is my system type. I will open it and choose sanitary for wastewater. The next aspect is pipe size, where pipe sizes are listed in inches. Since we had a metric template, I will consider the equivalent size of the pipe. If it says 4 inches here, I will use a pipe size of 110 millimeters, which corresponds to that measurement. The metric is 4 inches, and I will select it. In the first step, I need to adjust the height of the pipe. To do this, I will create a section along the main pipe. So I can select the section from the quick access toolbar or go to the view tab and click on section. So I will click a little lower to create this section and then slightly adjust its size. By right clicking, you can find it in 6th floor view here. So I want to model the wastewater for level 6 in the ceiling of the lower floor. So this means that the sanitary fixture are located in the finished floor level, FFL level 6, and the wastewater will flow down to the lower level. So therefore, in this level, I'm modeling the height of the pipes should be a negative value relative to this level since it is lower. So eventually, I need to consider the height of the beam that is the path of my pipe. For example, if I consider the wash basin, there is no beam in its path. Looking at the beam, it is located before the restroom space, so it does not limit me. Now I need to measure the height of my ceiling using the dimension tool. So clicking from here to a blank space gives me 35 centimeters. Thus, I will start modeling the height of 35 centimeters later. Later, if necessary, I can adjust the pipe higher or lower. I will go back to the plan, use the pipe command again, and input a height of minus 350 millimeters, which is what I measured before. So the fifth consideration when drawing pipes in their slope is their slope. So we set the slope in this ribbon under the sloped piping section. If we draw the pipe from the fixture towards the riser, we assume the slope goes downwards. To avoid mistakes, think of it this way. So when drawing, if you're moving away from your fixture and implies a negative slope, conversely, if you're moving closer to your fixture, that implies a positive slope. So closer means positive and further means negative. So now assume I want to draw from this fixture in the western restroom towards the riser while moving away from a fixture, giving me a negative slope. Set the slope percentage to 1%. Before drawing the slope at the pipe, I have 5 items to configure so that I don't forget them. I will refer to these 5 items as the left-hand rule. When you configure each item, you can open one finger. For example, after setting the pipe type, you open one finger, then diameter, middle, elevation, and slope value. So until all 5 items are configured, meaning all 5 fingers are open, at which point you're allowed to start drawing. So if you skip this process, mistakes can occur since there are many plumbing items requiring configuration. So and you may forget them. So we check these 5 items with our fingers before starting modeling. Near this fixture, I click once and move slightly towards forward. Our wastewater connection have a 45-degree angle to facilitate a smoother flow within the pipe. So here I will click towards the riser and press escape here. I can align this surface with the pipe axis using the align command from modify or by using the shortcut AL. After pressing escape again to cancel the align command, I will continue drawing towards the wash basin. I will select the elbow. It is positive here. From this side, it becomes a T-fitting. So if this elbow and this T-fitting are too close together, it may give you an error. So I will press Ctrl Z to undo and adjust this elbow slightly to the right to increase its distance from the other fitting. So now that I've selected the elbow positively, it shows an error setting. A line is too short. It means that the pipe segment between 2 fittings has become too short or for proper placement. If I bring them closer together, again, It may show not error regarding converted fittings. This means that the elbow is converting into T-fitting and it cannot be placed correctly due to proximity. So therefore, whenever these errors occur, it indicates that two elbows are too close together. Now that I've selected this elbow, I will use my keyboard arrows to move it upwards and create some space between them. So this elbow will then convert into a T-fitting. Next, we want to continue drawing towards the wash basin. The T-fitting I've selected shows a clip at the end. Right-clicking on drop pipe and check 5 items. So pipe type, fitting type, system type, and size. So all should be correct. So if you want to change the size of 2 inches or 50 millimeters fitting directly from this section, you can simply enter the size here because we want to use a one-way conversion. So we will draw the fitting with the same size and move forward. For now, you don't need to change the height as it automatically detects the height from the pipe itself. When you right click on it, so as I draw this slope, I will get closer to the fixture. Moving closer is a positive action, meaning my slope is positive or moving upwards. I will draw a piece of pipe and then press escape to view the section of the pipe along with my plan. I will close to views and use the tile views option to see both the plan and section same time. So now my screen is divided into the parts. The left side shows my plane and the right side shows this section. So I will temporarily remove the dimension line, select the pipe in both the section and plan views. In the properties window, check the vertical justifications in the of the pipe. Subject clips on the pipe indicates that is centered up in the justification setting is set it to bottom, which we move and clip down the pipes. Next, from the modify tab, use the split element command or SL. Click on the edge of the pipe. You will see that your cursor changes to a cutter icon, indicating that it is ready to cut the pipe. Click and then press escape to select the remaining section of the pipe. Choose your 2 inches or 50 millimeter one-way conversion. Again, and set its justification back to middle so that drawing continues smoothly. I can also move these fitting back a bit. If I draw this pipe again, I will place it here to show you. I will use the pipe command PI with a size of 110 millimeters at the height of minus 350 millimeters sloping downwards. I will draw this piece next to it just to show you. I will click on the positive slide of this fitting to make it a T-fitting. After clicking on the T-fitting, I will right click and select drop pipe, adjusting the slope upwards slightly as I moved forward. So next I will change the size of 50. If we draw it like this, I will move the section slightly forward so you can see that it becomes a symmetrical transition. In our wastewater system, we do not use symmetrical transition. Instead, we use a one-sided transition in this manner. We want to continue the path of the wastewater pipe to the sink. To accurately align with the sink, I can use a reference plane or a construction line. You can select a reference plane from the system panel at the end of this panel, or use the shortcut. Remember to always press RP to easily execute the command. So I will click on this and it reserves access to draw a reference plane. I can even extend it slightly further so the pipe will be positioned in the wall. So we will specify its again with a reference plane within the wall area. This means our groove will be made in the wall for the pipe. So from the intersection of these two reference planes, I will click the 45-degree angle. This means my pipe needs to reach the reference plane and then have a 45-degree angle to be positioned correctly. To continue drawing the pipe, I will select this and right click and scrape to access the draw pipe menu. We need to check 5 items: the connection type, which should be correct, the size 5, and the height is automatically detected, so there is no need to change anything. As you are getting closer to the fixture, the slope will be positive. So next I will create a vertical piece of pipe and click. As I said, I will create a vertical piece of pipe. If I change the height of the pipe here and move upward, a 90-degree connection will be placed between the pipe under the ceiling and this vertical pipe. However, we decided that our wastewater connection should be 45 degrees instead of 90 degrees, but for now, to correctly position the vertical pipe, I will move it up to a height of 4050 millimeters. So this means I have drawn a vertical pipe up to 450 millimeters in this section. So go to view, and 90-degree connection has been placed below. We will change out the connection later. For now, we're defining the path in this section. So if I set this view to architectural coordination, it will highlight everything clearly, showing the pipe in the ceiling. So I will select this pipe and move downward until it exits the ceiling. As you can see here. So we can switch to mechanical mode, so what only your pipes are shaded and cast shadows. Now I need to create the connection for this floor drain and draw my riser. So the first thing I need to do is to draw the riser in this section. My connection are at 45 degrees. I will click on the pipe and continue drawing it downwards. Right clicking the group for the draw pipe at the 45 degree angle, moving downwards vertically until I reach an approximate height. So I won't go all the way down, so I slip at the height and place a positive elbow here to create a T. Right click and drop up. It will be up. So coordination, I set it at the coordination mode so that I can see the walls. The pipe needs to pass through without putting it there. I will select the T and move it to the right using the keyboard keys, ensuring that my riser is correctly positioned. I switch back to mechanical mode and adjust this elbow slightly to the right, while in the same time moving the T down. We agree to leave some space between these corresponds to weight arrows in the software later on. So returning to the plan view, you can see that it has taken a T from here and connected it below the shower drain. Now we have a floor drain here connected based on this T for the western surface in the riser I drew. Since there isn't enough space for another T here, I need to consider an alternative connection for this floor drain pipe. We can create such a route because we have no other option, so we'll move backwards slightly and make this connection. So in this section, I will right click and select go to view in level 6. Look at our floor drain image. Returning to the plan view, I can draw a reference plane here or if it's not clear, create an RP reference plane from the here upwards. In plan view, we can see that this reference plane is displayed, so I will also extend it slightly from here and draw another RP reference plane. So those are necessary for me to accurately determine where my pipe connection will be located without needing to realign them later. So I clicked at the 45 angle for this connection. Now I can use the pipe command and check my 5 items. Connection type, which should be correct, size, which should be 50 millimeters or 2 inches, and height. What should I do? So I need to click in these areas, but the slope is not clear to me. To find out the height at this point, I will use the inherit elevation command. When this is activate, if I click on any point along the pipe, it will display the elevation of that point in the middle elevation section, effectively inheriting the height from that point. So let's activate the mid elevation feature. Let me remind you of 3 methods for determining height. First, I draw the initial pipe in this section. I set a specific height, which is then externed into the mid elevation. Second, if I want to draw from the extension of a fitting such as a T or elbow, selected and right click to access the draw pipe option. And the third method is if I want to take a branch from the middle of the pipe, I activate the appropriate command. So next I have slope as I approach the fixture, so the slope is positive and directed upwards. Here I will click at a 45-degree angle, which will create another T for me. Then I will move towards this dash line, clicking and extending until I reach this axis. So this connection I want to create here is a siphon type. However, to accurately depict this vertical pipe, I will extend it down to 0, which is the floor level. I play this setting and check in the section view. Now our vertical pipe has appeared down to 0 elevation, and I will adjust its other setting accordingly. After that, I can select the pipe and move it slightly forward using my keyboard arrows. So I'm adjusting it upwards. So far, my overall design has taken shape based on this space required for fittings and the architectural layout of the fixtures. I have identified the best path for modeling the wastewater system. So it is essential that it connects properly on the fixture, that I consider the correct slope for them, in that I can accurately depict the road from the fixture to the riser. These are important points for us. The routing of the pipes may also undergo some changes compared to this modeling we have done. I've removed the fixed services of the right side of the architectural model to directly integrate the fixed service into our MEP model. I intend to use this type to drain and floor trap to load the family for the shower head. Select the load family option from the folder of families provided to you in the under shower section, and then click open. For placing the system, I will choose the plumbing fixture option. Once the family is loaded, I will click in this corner to position it. So if it doesn't align with the walls, I can use the align tool all to do this. I will specify that this edge should align with that one. Next, I go back to the family tab and select the water closet option from the folder for service placement for the plumbing fixture system. I need to specify the type of host for placement. So I want it to be aligned on the vertical face of the wall at the height of 4050 millimeters from the service west to the floor. I can place it in this position for now and later adjust its height in the section view. So next I will load a flush system family from the section and click open. Again, for placement, I will select the plumbing fixture system option. Using the space bar, I can rotate it so that the connection screws are oriented correctly towards my service. I will click on the edge of the wall to place it. So now I will go back to the insert tab and select load family from the laboratory section, then click open for placement. The system option should be set to plumbing fixture and should be on the vertical face with a height of 800 millimeters above the finished floor level. So I will click here for placement. This is the edge of the wall. And later I can move it into the correct position in the plan. The last item I need to place is the floor trap. In the insert tab, I will use families from Revit. The Revit families can be found in this path: C drive, program data folder, Autodesk, Revit, your version, library, English US. I will navigate to plumbing MEP fixture and select drains using a rectangular floor drain and clicking open for placement. In this properties window of the plumbing fixture service, various dimensions are available. I know that the pipe connecting to this will be 50 millimeters in size, so I select the initial drain again. I will specify that it should use here place on a work plane, meaning it will be positioned on the work plane. So after selecting it, I need to choose the work plane in the ribbon, which is at level 6. In earlier versions, this work planes would be shown in the options bar. So I click here to place my full floor trap as well. I create a section because I want to specify the height of my wall hung service. After creating this section, I will make it a bit smaller and right click to go to view in floor plan. Here we draw an RP reference plane and align dimensions from this reference plane onto the floor level, setting that measurement at 450 millimeters for my service, or 450. Using the move command from above, I will adjust its position until they're aligned with this reference plane. So if you want to place a fixture in your MEP model, you can do this in this way. Let's model the pipe layout for this situation. I will use the pipe command to check 5 items. The connection type will be polypropyl, and the system type is set right with the size of 110. I will set the height to -350, which I previously noted in section. This level will be set to 1% upwards. I will click once for a 45-degree angle below elbow, and then click slightly ahead. I will apply a positive elbow to create a T. After that, I will right click on the T and draw a piece of pipe sloping upwards. Next, I will select this pipe and set its vertical justification to bottom. Using this split element command or the shortcut is all, I will create a cut on the pipe and select the remaining section. I will set its size to 50 millimeters and adjust its justification to middle. So I can move this transition piece slightly backwards. Using a reference plane RP from the center of the shower drain at the 45-degree angle. I will draw a reference plane to keep track of my path. If I want to draw from this point, it won't work because the transition would allow for a T to be placed here. I will click slightly ahead, right click on the draw pipe, and draw it in 45-degree angle. We can edit it later. I will apply a positive elbow to make it a T again. Here I will right click and do draw pipe and specify its slope upwards. So I need to define the path again using this the same reference plane RP from the center. So I will draw a reference plane from the wall and another one at the intersection at the 45-degree angle. So I will right click on the draw pipe and extend it to this axis. Then set its height to 450 millimeter and apply it. We can adjust this later. In this section, what I will do is right click on the draw pipe and bring it over to this side. Then I will move the elbow slightly left to get closer to the T. I will select both the elbow and T and align them with the drain using an align LL command to ensure they are properly oriented. So I will create a section in this direction and collapse it. So right click to go to view. Before finalizing this section, I need to adjust the height. I will move it down in 3D view to see how it looks. Selecting the box, we see there is a beam in this service area. So my height restriction is this beam. So there is still little room for it to go higher. Going back to the plan where we were drawing the riser. So I will right click on the draw pipe at a 45-degree angle and extend it downwards. So I will apply a positive elbow to make it a T again. So with this T selected, I will right click and drop a piece of boards due to the short distance between this elbow and T. I received an error message, so I will move the elbow to the right to increase that distance. Once again, I right click on the T and drop a piece of boards, which will create another section of pipe. So I will then move the pipe to the right so that its position is exactly between the walls. Returning to my plan. Now for connecting this shower drain, I need to do it similarly on the side using a reference plane RP. From this connection at the 45-degree angle. Using the pipe command PI, I will select propylene fittings with the smallest size of 50 millimeters. I want to take a branch from the middle of the pipe. So I will set it both to elevation accordingly as I'm getting closer to the drain. So the slope will be upwards at 1% after clicking at 45-degree angle from my next point. It seems like more space is needed, so I will click here again another 45-degree angle towards that direction. Now that we've crossed that line, I bring these points closer together. So it appears that this always direction is incorrect. So we'll select it in the properties window and change its orientation. This means it needs to fit into this T socket. I adjust its position slightly closer, moving both the T and this elbow backward within certain limits. So I cannot apply a 45-degree angle here directly. Instead, I right-click on the draw pipe at the 45-degree angle again, so it seems there's still some restrictions, so I'll put it slightly forward and draw it out. Now let's correct these elbows by selecting both with control and moving them slightly to the right. After selecting both, I ensure their direction are correct so that they're aligned properly with their sockets according to flow direction. So I bring them closer together as needed. Finally, we need to check if we can fit this siphon in this space. If not, we may need to raise everything slightly higher. So I proceed with that adjustment now by selecting these pieces and bringing them forward as much as possible until they reach this limit. So after that, I lower this elbow again slightly. Now aligning this connection with this pipe should be done correctly. Then the first item I need to check is whether it fits well in this area. So it seems that the siphon might not fit in this section. I right click and go to the view, use the pipe command PI to check 5 items related to the connection, system type and size. Since I want to draw a vertical pipe, the shape is not an issue in this area, so I will click on the connection point for the shower drain and draw the vertical pipe. Then from the system tab, I will select the pipe option, pipe fitting. By clicking here, I can create this connection. So using the Align AL tool, I will align the pipe with this plane. As you can see, these two pipes are very close together, so I need to create a bit of space for this pipe to connect properly to the siphon. So I will return to the plane, I'll select this elbow and uncheck the visual socket option in properties window. This elbow actually needs to fit into the socket of the next elbow, so we can lower this elbow a bit more until I encounter an error. That means it cannot go any lower. So returning to the section view, you can see that a gap has been created between them. So I will drag this pipe and use the top key to connect it to the edge of the siphon. This way we have established a connection in the section that aligns with this pipe. I will compress it a bit. I will right click and go to view. You can see that this is our BIM and the pipe has been passed under it. Now I right click and use draw pipe with an upward slip until I reach a little higher. Then using the Align AL2, I will align it with the floor level. Returning to the plan, I will move this section to connect it to the floor drain again. I will use the pipe command PI and draw a vertical pipe with the size of 50 millimeters. So the shortcut for pipe fitting is PF. I will position this siphon and rotate it once or twice so it fits correctly. After that, I will align this pipe with this point and then drag it to connect the siphon to the pipe. So the last item is the connection for the sink. In a 45-degree section, I will slightly adjust my section and bring it back so that I can see only the pipe within the frame. I will right click and go to view, then I will delete this elbow. Right clicking in the pipe, I will use drop pipe at a 45-degree angle and pull it slightly back. Now using trim TR, I will adjust this pipe between connections and lower it a bit more. So we want to draw this side, so I will create a section along the pipe we want to draw. After creating the section, I will right click and go to view. Then I will select the pipe and click on the clamp to use a drop pipe with a slope of 0 and move it slightly forward, selecting the elbow. I will apply a positive angle to make it a T. Now we can draw the vent. Let's take a look at this in 3D. Here we have a beam. Which one was our sink? Let me open this side slightly so we can see that our western service area here has both the floor drain and the sink located exactly under the beam here. So I cannot maintain this pipe's path from here. So looking at the plan, we can do that. So we can extend this directly. Let's try that out. Right clicking, I will drop it with an upward slope until here, then up to a height of 450 millimeters and apply it. So in 3D view, you can see that there is now much less interference, but there is still some overlap. So I have another option. For instance, if I place a bend here towards this side, it would be the best position for the sink. If I want to position it here near the entrance door, there might be some interference. However, I can rotate the sink in this direction. Let's try it out by going to the System tab and selecting Plumbing Fixture here, and I will choose the sink family in the vertical face with a height of 800 millimeters and click on this wall for placement. Now I will delete this pipe that I've drawn before, as well as those sections that extended vertically. So I will drag the pipe back slightly and right click with an upward slope at a 45-degree angle until reaching a height of 450 millimeters and apply it again. So in 3D view, let's open this slide slightly. Now it's positioned correctly. So here I will select this vertical pipe and make a copy of it to place here. It looks like a good position if I want to have the sink on this wall. Looking at the plan, you can see that the outlet pipe comes here. If I want to position the sink, I can go back to the System tab and select Plumbing Fixture again with a height of 800 millimeters. Now looking at these areas on this wall, I can place it in this position. After that, I've configure its outlet from the wall at the end angle so that it connects properly to the sink's inlet. Thus, there are two solutions: either move the sink slightly left as far as this wall allows, or adjust its position accordingly. So you will either place the sink on this wall or consider these two suggestions regarding the plumbing. We can evaluate which position we approve so that we can choose any of them that we want. We want to model the drainage of this slide. I will use the pipe command and check 5 items for propylene. I will set the size to 110, the height to minus 350, and slope downwards at 1%. So here in this area, if I click a bit further, you will see a 45-degree angle indicating alignment with the riser. So if it doesn't show the alignment, you can later use the alignment command to adjust it. I will also move this elbow slightly to the left. Now using the line command, I will align this surface and the pipe axis. So next, let's adjust our height. I can select this piece of pipe and use the selection box option in the 3D space. Currently, it is colliding with the beams in the structural floor, so we will lower it slightly to place it in the suitable situation. So now I will first connect the pipe to the riser by creating a section line with the pipe I want to draw. So we ensure that only this pipe is included in this section. After that, right-clicking and selecting Go to View, I realized that I cannot make this connection from below, so we need to use another fitting. So I use Pipe command and click for a 45-degree angle and select this T-fitting, moving it slightly higher. Then using the trim shortcut TR, I will connect this pipe to that one. So returning to the plan view, I will create a connection for the sink. So the sink should rotate in this direction to connect here. Let's start with PI, propylene size 50. I want to branch off from the middle of the pipe. So both elevation slope will be directed upwards. Here I will click for a 45-degree angle. However, there isn't enough space for the T-fitting. I will adjust the elevation slightly lower and try again with another 45-degree angle, but still find it cramped. So next I will select these two elbows to correct their direction, setting them to positive since they are close together and cannot perform as needed. So I will move one elbow to the right to increase the distance between them. So I will select this one and uncheck the virtual circuit option, moving it left until it is close to the elbow without causing an error. To create more space, I will temporarily raise these two elbows. Re-entering the pipe command PI, I will create an upward slope with an 45-degree angle. Now that the T-fitting is positioned correctly, I can select it and move it downwards, but it cannot go lower than this point. So I will deselect the virtual circuit option and lower the T-fitting further. In the first section, I will check the direction of my elbow, so it is reversed. So I will select it and set its direction to positive. Now I will bring this T-fitting as close as possible to that elbow. Continuing with the layout, I will select this pipe and right click for a 45-degree angle upwards. Now I will move this elbow to the left so that it gets closer. Afterward, I will select this entire space, this piece of pipe, and move it to the right for balance. Alternatively, I could lower this pipe piece as much as possible while keeping its alignment in mind. So I will also shift this piece of pipe downwards. This one. And this one is that I shifted this piece downwards. You can choose this elbow and check the virtual socket option. If you don't do that, nothing major happens. It just improves visual clarity. So now using the align command AL, I will align the sink axis with this pipe's axis. So if it needs adjustment inside here, you can manually select it and move it slightly right. Now using AL again on this and the pipe axis, since they're very close, another minor adjustment is needed. So bring this elbow slightly right again, aligning it with the sink axis. Now places it in a suitable position. So let's see how far forward I can bring this by selecting it until it reaches a relative position. Here. Then using align command again for exact positioning of both axes. So I will connect it to the surface, right-clicking and drop pipe, then an upward slope until reaching this axis. So I will apply it until 0 height and apply it. Next, I work on creating its connection section as well. So for this pipe, I will also right-click on drop pipe with an upward slope until it reaches the wall. So then click until reaching a height of 450 finally in this section. Here, I will clean up using a 90-degree elbow in this pipe by right-clicking for a 45-degree angle elbow placement. So I will move it back a bit and use the trim TR command to connect these two. Then right-click on this pipe to draw it a little further ahead without any slope. And I place a positive elbow to create a T-fitting. Now let's go back to the plan view. We want to connect this side with a section aligned with the pipe that will connect to the fixture. I right-click and select Go to View here. I remove this elbow and connect the pipe fitting PF to this siphon. Next, I will use the Align AL command to align this edge with that point by dragging and pressing Tab to connect these two. For the service of this side, I want to place these fixtures into the plumbing model. From the Insert tab, I will choose the Load Family option from the folder of families provided. I will select the Eastern Water Closet from the folder and click Open to position it. In the System tab, I'm using the Plumbing Fixture option and rotate it using the spacebar. Once or twice, I need to ensure that there is at least 25 centimeters from the fixture to the wall in front and at least 35 centimeters to the side wall. So I press VV to hide some categories and check important categories and click OK to better see the walls using the Align Dimension tool. I will measure this distance to the wall edge. If it doesn't show the edge, I can select it by pressing Tab once, clicking and then selecting an empty space next to the wall edge with Tab again. To change these distances, I need to first click on my fixture and then adjust its size to 250 centimeters, which is the minimum We have set this one to a minimum of 450 centimeters. After adjusting the drain lines, I will delete these 2-dimension lines to avoid clutter. So returning to the insert tab, I will select the second option from the flush system folder and click open. I want to place a belt in the flush tank for system service. The system tab, I rotate it using the spacebar here and click in line with these fixtures. So if it doesn't align correctly, I can use a line AL to help position it. For the sink, we had loaded its family earlier since we are using the side tool in vertical mode and the height of 800 centimeters here. I click on this wall for placement to model the piping path. I will use the pipe command or shortcut PI for 5 items. So I will check polypropylene size 110 starting at the height of minus 350 centimeters with a downward slope of 1%. So I click near the fixture and move it a bit forward so I can place my elbow later. Then I click at the 45-degree angle and go down here. I click here. If I drag this here, I can extend it towards where this pipe connects to the fixture. Now using a line AL, we'd align the pipe with the fixture's axis as well. So this elbow. In properties window for this elbow, I uncheck the vertical circuit option and move it right until it gets close to the other elbow. If there is an error, I will cancel it. By dragging, I will select these and move them slightly left for better position relative to the riser. So I will use a line. So this X and that one will be line. So let's first make the connection to the riser here in this section. I can also check the height of the pipe in this section by right-clicking and go to View. Here I can lower it slightly so that there is no interferences. Let's take a look at it in 3D. So I select it and use selection box. You can see that there is a beam in this path, so it goes straight through here and can connect to the riser. So I open this side a bit. Our limitation is here because I have a sink in this area. So I select one of these vertical pipes for the sink and copy it from that pipe, from its aux. Then I place a pipe in the sink area in 3D spaces. Let's check if it falls on a beam or not. So I've opened it up a bit from the side in this view until we don't see our ceiling. So if I want to place it in position for the sink, it falls on a beam here. If I want to move it too far away, the sink position may change completely. So I move this pipe here so that it's placed after the beam in plan view. Now we can make the connection to the sink. So I will connect this pipe to the main line and then proceed with connecting it to the riser. Since there is a beam here that limits our height, for my fixture I height it with edge using the pipe command PI. I take a peel-in pipe size 50 and branch off from the middle of the pipe while keeping the slope upwards here. I click at the 45-degree angle again for another 45-degree angle on this side. I click. We can make adjustments into this three-way connection. You can bring it closer here, but only if I change this elbow joint to a different type of positive connection. I will also select this, modify the types of these two elbow joints in this same way. I can reposition this one so that it gets closer between the elbows. So if you remove the visual socket, it will look better up to this way. Now let's move to this section. So I will expand the section a bit and shift it slightly to this so I don't see the main line. Right clicking, go to view. I need to lower this pipe because it needs to pass under the beam. In 3D, let's take a look at it and gather this side a bit more. So you want to pass under the beam and connects to this three-way junction. So now that we have adjusted the side, let's connect it to the riser. So right clicking, go to view. I need to take a branch from down here using the pipe command PI, setting 45-degree angle as much as possible. I will bring these connections closer together so that I can place an elbow here. For that, I need to rotate the first elbow to the correct direction, and then I will remove the virtual socket from this, and I will move this three-way junction as close as possible to the elbow so I can get it any closer. And then this. Now I will select this three-way junction and remove the virtual socket to hide it. Then I will move this three-way junction up as close as possible to the other one without going further. Let's see if I can move this three-way junction back in the plan. Yes, there's a space. I will select these, holding down Control, including the three-way junction, and move them up as much as possible. So I will also move this elbow in the same way. Now let's return to the section and use the trim command TR in this pipe. So it seems we still don't have enough space for the connection. Let's go back to the plane and remove the virtual socket from the elbow. Then I will deselect here. I holding down the shift and clicking on into the bring them closer together again. So now returning to this section and using the trim command TR so it can finally connect. You can now remove the virtual socket from this three-way junction. So we'll hold down the Control and lower it between the elbows, bringing them closer together. So I will also check the visual socket on the previous elbow again. Next, let's connect to the wash basin in this section. Right clicking, go to view, right click, draw pipe. Here we have 45-degree pipe here. I will move the elbow further back and connect it using the trim command and connect these two. If it doesn't work, try the reverse connection, and this is now correct. So On this side, right click on the draw pipe and move it slightly forward without slope. Then insert a positive elbow to create a three-way junction. Now we will draw the connection to the eastern service area in this section, which I have opened it up. I right click, go to view and use the pipe command again. When we have a fixture model of the plumbing system, I connect the pipe to the fixture. However, when we don't have one, on this pipe, I draw the pipe at the 90-degree angle and then remove the 90-degree elbow in this section before placing this siphon. Here I will set the pipe size to 110 millimeters. I draw a vertical pipe. Because the size of the fixture outlet was not compatible with the pipe size, therefore it created fitting for me, so I can select the fixture and edit this type and find where it needs to connect. So to the flush radius section where it connects to the flush tank, so we will click on edit family, selecting the connector with sizes including a 2-inch radius. So the units of the length 2 millimeters, 2 decimal places, and ensure that the symbol is displayed. Okay. And for the fixture size of 50.8 millimeters, I set it to 55 for the 110 millimeter pipe radius, which becomes 55 when loaded into the project. Our conversion has been removed now. With pipe fitting PF, we have connected one leg to the trap here at point AL, axis of the pipe, which is siphon. By dragging it and clicking tab, we have connected them. So the drain connections in both areas were fixtures and in the architectural model or were in plumbing model. We want to draw the ones for these restrooms. Looking here, the ones for the wash basin in the western toilet has reached the riser. Similarly on the eastern side, so the ones for eastern toilet and wash basin have also reached to the riser. So we want to model this path in my model. The first thing we always do is draw the vents for the wash basin. To draw the vent for the wash basin, I will create a section aligned with the fixture. I will compress the section a bit, right click, go to view and open small part from the top so we can see the ceiling. If there is a three-way junction, you can select it and use the double heated arrow to rotate it into the correct position. I will use the pipe command to check 5 items. Polypropylene system type is wet. The one size which is 50 according to the plan. Slope for wastewater is opposite, meaning if I'm moving away from the fixture, my slope will be positive. I want to consider slope of 0.5%. Here there's no slope, so I need to enter the mechanical setting window to change it. I can open the mechanical setting window in 3 ways. Through the Manage tab, selecting MEP setting. Under mechanical setting, the second way is through the System tab by clicking on the small arrow next to the plumbing and piping. That window will open. In the third way is using the shortcut MS. In the slopes section, I will enter 0.5% for the slope and then click OK. So now I will go to the connections point of the pipe and click on this purple circle, moving up until I reach below the ceiling and then slightly forward. The vent connection are at a 90-degree angle. How high I go depends on what items are under this ceiling. For now, there's nothing here, so I will consider it at a certain height. Later, when I bring it down to the lower floor, I will adjust the height accurately. So I cannot see the vent here due to view range setting. I can open my view range from the properties window or using the shortcut VR. The top should show me up to 2 meters below my upper level. Let's see what happens in our upper level section. It is 2 meters below with as reference plane. I will set an offset of 2 meters upwards from this side, which means I want to be at this level, but want to see up to 2 meters lower than my upper level. So if I want to see the vent, I will set the view range to 0. Okay. Let's see if it works. Now I will raise the suction header slightly higher. This should show where our riser vent will be located. Checking the size from the plan, it seems there's no size provided for the riser vent in our overall plan. Let's look at the riser diagrams to see if we have anything. Our drain is related to wastewater. We generally consider 2 inches or 50 millimeters for vents. So I want to draw a vertical pipe sized 50 millimeters here. Using the pipe command, I will set it to size 50 from height 0 with 1 click up to about 3 meters. Apply that in this section. Let's see that. From height 0 to 3 meters, the vertical pipe has been drawn. Now there's space for me to bring it closer to my wastewater riser. This one pipe should reach here. I can right click on this pipe and adjust its angle upwards with a 90-degree connection. Aligning it here with the reference plane. After that, I can use an line. This is my base line, and I will align it properly. You can even move this back or place a 45-degree connection here. So I will remove this elbow and clean up some connections. Now I right click on this pipe, draw pipe, and set an angle downwards at 45-degree. Align this reference with it now. For connection purposes, I can create a 45-degree section or even trim it in 3D space by right clicking and go to view, TR. Next, I will move to the vents related to our western restroom. For this service, I need to bring the vent pipe close to the nearest wall and then go up through that wall so that I can connect it. The nearest wall can be either here or on this side, it doesn't matter. The pipe will come through here into the wall and go up before connecting here. To make a proper connection, I will press VV in the first plumbing fixture tab and uncheck it. So that sanitary fixture not shown. Now I will use the pipe command again for polypropylene, vent size 50. The pipe should be directed upwards. I know that the height was initially negative, so we pulled it below the floor for now. I will set the height to 0 and adjust it in the section later. The slope of my vent is positive when I move away from the fixture, which is the positive opposite of the wastewater slope. Here I can click at a 45-degree angle. However, it doesn't need to be at 45 degrees since this is a 90-degree elbow that will rotate. I must ensure that I come close enough without interfering with the flush tank. So let's reload the plumbing fixture here. I've checked the box to hide them. With a reference plane, we can define this area. After that, with VV, I will uncheck the plumbing fixture to hide them again. Now I will use the pipe command. I can click here to define the area. I will go a little further and then click vertically to see how high it should go. For now, I will set it to 3 meters. This will draw it up to 3 meters in height from now on. So it will be drawn at the height of 3 meters. Let's check it in 3D. It's better to set this section box to mechanical mode. I mentioned earlier that it should be from 0 height, but now I need to bring it lower so that it comes below the ceiling. It has come up into the wall at the height I specified. Let's adjust the height of our vent in this section. I can select this section and right click to go to view. This is our ceiling, and you can see how far down the vent can go. It appears that when we brought it down, it came out of the ceiling, so all pipes need to be lowered in height. To adjust the height, I will create a section that clearly shows this line. So right click and go to view. Since the 45-degree connections have brought it lower, it will be very easy to adjust. I might need to open this up a bit more, so especially on the side where we have the instant service, so it also needs to come down. What I will do is to drag this area, excluding the vertical pipes. I will hold down Control and select only the elbow without selecting the vertical pipe. Simply, I will bring this vertical riser down until it no longer interferes with the ceiling. And as to come down further, so let's go back to the plane. These things to connect properly. They're at the different heights, so I will use the pipe command to check here, PI, to check polypropylene size 50. I want to take a branch from the middle of the pipe, so my slope will be positive, so of the wastewater. As I approach the fixture, my slope will be negative, so here you can see that highlights the left pipe, which is its axis. When I move it, it gets highlighted. I will click over here where all my connections are at 90 degrees and align them in one section along the pipe. So I right click and go to view, or align them in place, or it's easier to delete this part using trim, TR. And now connect these two. So now regarding the connections I wanted to make for this vent section, its system type has become sanitary. If I press Ctrl Z again here, you can see that it has happened again. I press Ctrl Z one more time until these two system types are correct. For now, I will delete them instead. I will trim this connection. So let's check if everything is correct with these system types and connections position, or after connecting them. Now that's connected, we delete this part and return to the plane where this section was drawn for the wash basins first. So let's gather this area a bit by right clicking and going to view. I'll check again using PI for polypropylene when size 50. Since height doesn't matter in my section, my slope is opposite to that of wastewater. It means it became positive as I moved away from the fixture. I click a bit above. There's an issue here. If I extend the pipe in this direction, my wastewater pipe is exactly aligned with it. So in fact, the vent from the lower floor is coming up from underneath this point as well. So I cannot support both since they're in line. It's better to draw the vent here at a 45-degree angle while being mindful of its slope. Notice that how the slope decreases. Click on it and enter half of percent, because dragging has reduced that slope. Now I can continue over here and right click pipe shape. It's still directed upwards. I come up to here. For my vent where all connections are at 90 degrees, however, if it becomes 45 degrees, that's also acceptable for Eastern service vent. So if we're being the wall closer, for example, here or this wall, so I will use the pipe command and select polypropylene. When size 50 with the height of 0 and slope directed upwards. I will click here and then move a little further to see if it can place the T-fitting here. Yes, it is placed. Now I need to determine how high it should go. I will say it should be at the height of 3 meters. From this point onward, I want it to be drawn at the height of 3 meters. I click here and then make another click here. Now, what should I do? I want to connect this positive elbow to the T-fitting. So I will draw a piece of pipe from this T-fitting. I right click and go draw pipe and set the slope downwards to draw this section. The connection between these two will be made in the section view. I right click and select go to view. Then use an alignment tool to set this as my reference point. I will align it and then use the trim tool to connect these two parts. Next, I will return to my plan view and bring this section here. I right click and go to view. And since I've drawn it from a height of 0, I will select it and lower it until it is just below the ceiling. It cannot go any lower than this, so this position is also suitable for me. Now let's take a look at this piece in 3D. I will select everything using the selection box. Notice that all the waste water pipes for this floor, especially in level 6, connect to the ceiling of the lower floor, and their vents run up into their own ceiling. This means that any services area, either eastern or western, all sinks must have other ones moving upwards. So now the placement for these sinks is always clear. I cannot bring them down. Those sinks always go up. First, I will draw the sinks to know where my vent should be located in ceiling. After that, I will try to run a pipe from both the eastern or western service areas up through the wall to reach the pipe that is under the ceiling of the floor. For exercise, you can draw the vent for this service yourself. Start with the sinks, this sink and this sink, and then I will take the vents for the toilet service up through the wall until it reaches the main vent line. I will do the same for the eastern service area too. We want to model the kitchen drain system. In the kitchen, there is a 2-inch connection for the sink and another 2-inch connection for the washing machine or dishwasher. So we have placed both the washing machine and dishwasher here, along with the floor drain that connects to the riser. So our goal is to model this pathway. So start by using the pipe command for polypropylene type sanitary with the pipe size of 3 inches or 75 millimeters for the height. I will initially set it to -400, so then I will check the section in relation to the ceiling and beams, ensuring a 1% slope upwards. So I will click forward a bit and then create a 45-degree angle for the pipe. So this will change the size on this side as well. So I will move it slightly forward and place a positive elbow here to create a T-fitting. So I will select the size and set it to 50 millimeters or 2 inches. So from this section, we can directly change the size of the T, but on this side, we definitely need to have a one-way converter. Now I will align it. I will consider the position of the sink and align this pipe accordingly. Here I will right click on the draw pipe and draw a section of pipe sloping upwards. So I will select the pipe and set its vertical justification to bottom and name it with SL. I cut it, so I will continue with this pipe, adjusting its size 50 millimeters, setting its justification to middle. I can even drag this conversion down a little bit if needed. So now I will right click and use the draw pipe command to bring it slightly forward. According to the map, I cannot place the floor plane drain exactly where it is. It needs to be moved slightly forward due to the conversion. Therefore, I need to guide a trap for it. I can leave a comment indicating that the position of the floor drain and be slightly adjusted. So I will continue until I reach the wall and give up to the height of 500 millimeters, applying each step as I go. I will change that 90-degree elbow now. Using the pipe command PI, I will set it to polypropylene type sanitary size 50 millimeters and take the height from the middle of it with the slope upwards. I will click here at a 45-degree angle, then again at the 45-degree angle as I go into the wall up to a height of 500 millimeters. I will apply each step again. After this, I can raise this pipe a bit higher or move this elbow up slightly to make space for the pipe as well. I will lower this elbow down. Now I can also raise this to fit in closer to this elbow. It gives us our pathway. So the floor drain has not been placed in the architectural model either. So we need to position it in the plumbing section. Under the system tab, I will select the plumbing fixture. From the loaded families in the properties window, I will choose the first option and set my work plane to floor for this level. So in work plane FFL, so I click there. This is the reference plane from this pipe with 45-degree angle, and I move it and release it here. So I can delete reference plane, so I will create a section aligned with this pipe so that I can make the connection to the floor drain. After reviewing, I right click and go to view. I realize that the height has not been correctly chosen. This is actually from the floor level, so to check from the furthest point, I will examine this section in line with our washing machine, right clicking and selecting go to view. I see that there is indeed a beam here, which means I cannot bring it directly through the beam and it needs to connect at the 45-degree angle. So this beam is present for both our sink and washing machine connections. As you can see here. So considering this beam and taking into account the ceiling height, I need to lower this pipe significantly. What I will do is remove the elbow and move the pipe slightly to the end, to the right, actually effectively shortening its length. So right click and I will drop it at the 45-degree angle upwards. Then again at another 45-degree angle. Now another one. So I can use the trim command TR to connect these two together. We had to draw a line here to bypass the beam, and I will bring it forward until it gives me an error message. We're moving all of these slightly forward so that they're not too close to the beam. If adjustments are needed later, structural items should not cause any issues. I will lower these two pipes with control and bring that elbow down slightly as well. This way we have successfully established our connections. Selected those upper elbows while holding down and uncheck visual socket in the properties window to improve the appearance and functionality. I can move this elbow back a bit, but not too much due to the presence of the beam. So therefore, where we have the beam, I will set it up like this. So the connection is like this, and intended to connect to the floor drain. So I adjusted the height and added the bend here. And now let's go to floor drain. So I use pipe command to draw a vertical pipe with size of 50 millimeters made of polypropylene using the sanitary system. Next I will use the pipe fitting command PF and click to position the sink with this rotate tool. I can turn it without cancelling the pipe fitting command. If you press escape and cancel the command, you can select it again and the rotate option will appear with align this point of the sink. Second, using the align tool by dragging and pressing tab, I will connect these elements together. Since I have one-way converter here, when I will try to connect it, it defaults to a symmetrical configuration. To correct this, I will use the split command SL to make a cut here and then delete that section. Now these two pieces of pipes are separated, so by dragging this pipe to connect it to my siphon. Now using the trim TR, I will connect these two pipes together. If you want to connect to the often after using one-way converts, there could be issues, so I will bring a connection a bit forward. Since my floor drain has shifted compared to the plan, I can leave a comment about the adjustment. Now I need to move the section slightly. Here, I right click and select go to view here. So I want to draw the connection to the riser downwards. I will right click and use the drop pipe command at a 45-degree angle and come down until a certain point. I select the positive elbow to create a T-fitting. Then I'll choose another elbow from its correct connection type and right clicking here and the T-fitting to drop it slightly upwards. Looking at the plan, it's clear that this riser needs to be moved forward a bit to pass through the wall. So far we have outlined the drain system for our kitchen. Here we want to drop the vent for the dishwasher and washing machine and connect it to the riser. So the location of the riser is here. First, I will set the position of the riser according to what is shown in the plan. I will use the pipe command, selecting polypropylene for the system type, and the vent size will be 50 millimeters. I will set its height at the 1 meter above the floor without slope. Click here, and from here to 3 meters above the floor, I apply it. So now I will create a section in the direction and adjust it slightly. I will right click and select go to view. I create this section in order to check its position with the beam. Now I a bit more compacted so that it fits exactly within the pipe boundary. So if I check this section again, it should be positioned here, but if this interfering with the beam, this means my vent pipe needs to be placed here to go above it and continue through the lower floors as well. Now this position is also interfering with the wastewater pipe, which is also obstructed by the beam in the current location. So let me select this section box and take a look at it in 3D. I will switch this 3D view to the perspective mode and rotate it a bit, coordination mode I mean. As you can see, it currently interferes with the beam. So in this right view, I will hold down the control key and select the fitting elbow, moving it slightly forward so that it can bypass the beam from this side. Let's take another look. So I will extend it a bit and right click to go to view. It was still interfering with the beam in this direction. If I move it a little further forward, we can just focus on the wastewater. I right click and go to view again. It needs to shift slightly to the right. I will select it and move it to the right where there is a space. Now that it has moved to the right, it does not interfere with anything else from this point onward. We can render our pipe, so this piece of riser is not useful for me because anything I want to draft here interferes with the beam. So if I had placed the vent here, I could have moved the wastewater pipe slightly further to the right. So I will select this and move it more to the right. So bringing the riser forward so that it aligns properly. Now let's draft the riser for the dishwasher and washing machine. So I will bring this section here and right click to go to view. If we move this upward, it is facing a window, so it would be better if I create another section on this side for a clear view. So I will also compress this section a bit, right click and go to view. Notice that here it reaches the window. I will switch it to the coordination for better visibility. For now, we can move this vent below the window so that one vent connects to it, and then the laundry vent connects below the ceiling, since if it were to go straight up, it would hit the window. So in this section we had earlier, I will use the pipe command again, PI, to check my items. Polypropylene connections with a vent size of 50 millimeters. Since I want to draw vertically, the height does not matter here. I will give it that slope and have a person and start from the level of my sink. So now it needs to move through the wall. So it's better to check in this section. Under other section view, I will switch in mechanical mode, selecting this pipe. So I will right click and choose draw pipe with slope upwards of 0.5% until it reaches the point. So next I will return to my previous section where I will use the pipe command. You can see how it looks on my side. I will move it here and right click, go to view. So here, pipe command, PI, I go upwards. This should connect into the ceiling from the front section view. These two needs to connect together. I can use the trim extend tool for this purpose. So this serves as my basis. All three lines must be aligned so that their connections are correct. I open it, so right click, go to view. So if they're not aligned properly, for dishwasher and laundry, they should be slightly ahead or behind. If they are slightly ahead or behind and they're not aligned, then I can use the line command here to adjust them together along their path towards the riser. So this cannot come straight, because if it does, it would align with my wastewater pipe, so making support for both pipes is impossible. So I will drag this pipe at a 45-degree angle or 135 degree from horizontal. If its slope gets misaligned, I will apply 0.5% slope for it. So continuing my path, draw pipe. So I will draw the riser using the interference plane by selecting this reference plane with align the pipe fit. So we can take a look at this in 3D. I will select all these pipes. To do this, I can either drag, or as I did, hover our one pipe and press the tab key once, twice, and 3 times to highlight all of them without moving the mouse. Then I will click to confirm the selection. From the ribbon, I will use the selection box command so that I can view the section in 3D. Look at here, it has moved up. I can switch to mechanical mode for better visibility. So the wastewater vent is also moved up. Now we want to connect this to our riser. I will bring this section over here and adjust it so that I can only see the vent pipe inside the section. Right click and go to view. So for connecting the riser, then right click and just draw pipe, slightly raising it at an angle towards the type. I press the escape key. I will select the pipe again and click it a 45-degree angle to connect it. I can also lower this fitting. The vent from other floors will connect to this junction as well. We have the same layout on the kitchen side. So by pressing the tab key once, twice, or 3 times and clicking, I will select the pipe. Then I will click on the mirror command. Now I need to define an axis as a reference point here. I will draw it out like this and zoom in a bit using the directional arrows on my keyboard. I will move these pipes to the right. So after zooming in a little, let me zoom in a little. I think I have positioned them appropriately now. They're okay.